Hello and welcome to m252 Calculus 2 here at Cañada College. My name is Lapuz. In this video we will be doing checkpoint 3.29. This is from section 3.7, improper integrals. This problem wants us to use a comparison test to show that the integral diverges. So integral diverges. Okay. Let's see if this in fact diverges. So we have 1 over x, or ln x over x is our integrand. What we can do is we can assume that ln x is bigger than 1, which it is as long as x is bigger than e. And here x is bigger than e, so we'll make that assumption. Ln of x is bigger than or equal to 1 for x bigger than or equal to e. And once we know that, we can divide both sides by x. Now we're dividing by a positive number because, again, we're looking at going from e to infinity. So with x bigger than 0, ln x over x and 1 over x, divide both sides by a number bigger than 0 will not change the sign, and so we have this inequality. So we're saying that this ln of x function is bigger than 1 over x. So imagine what 1 over x looks like, because that's the easy one to do. 1 over x looks like this. So whatever ln x is going to look like, starting from e here, ln x over x will be a function that will be bigger. So let's say from here it will be bigger. So ln x over x function is bigger than 1 over x function. This is 1 over x function, and it doesn't touch the x-axis, but we know that ln of x would be bigger. All right. So that would be what we will compare it to. So compare with, and we're going to compare it with the integral of 1 over x from e to infinity dx. Okay, so let's see what happens to this integral. I'm thinking that since ln x is bigger than that, we're going to probably want this thing to diverge. And if it diverges, then this will necessarily have to diverge because it's bigger. Okay, so let's see what happens to the integral of e from e to infinity of 1 over x dx. This is an improper integral, so we're going to need to take the limit as b goes to infinity for some value of b, e to b, the integral of that from e to b of 1 over x dx. All right, we know that this is going to be the ln function, and we have not taken the limit yet, so we'll keep the limit symbol here. This is going to be ln of x from e to b, and this will be the limit as b approaches infinity of ln of b minus ln of e. ln of e is equal to 1, but more importantly, what happens to b or what happens to ln of b as b goes off to infinity? So what happens here is a question mark, and the ln function, I seem to rely on graphs a lot to see what happens to certain functions, but if we let b go off to infinity, b, some value of b here going off to infinity, then the ln function, I know it looks like it has an asymptote, but it does not have an asymptote. It grows, continues to grow slowly, but nevertheless still continues to grow. So ln of b will also go to infinity. So that means this thing goes to infinity, and now this thing's going to diverge. Diverges, and maybe more specifically we say it goes to infinity. Okay, now since since in our comparison ln x over x is bigger than 1 over x, then the integral from e to infinity of ln x over x dx, this is infinity, is going to be bigger than integral from e to infinity of 1 over x dx. And we know that this thing, we just showed that this thing diverges. And we have something that is bigger than that, so this thing will also diverge. Right? Because we have something that diverges, and then we're comparing something bigger than that, and so this thing also has to diverge. So therefore, we can say that the integral from e to infinity of ln x over x dx also diverges. Okay. All right, that's it. Hope that helps. Good luck.